Hello and welcome back. We have covered lots of ground on correlation and covariance so far. We have understood what is covariance, what are the drawbacks with covariance, how it actually shows you the direction only, not the strength. And then we understood correlation will show you direction and strength both. And then we understood correlation always shows you the linear relationship, and there may be some non-linear relationship also. You definitely need to do a scatter plot before you make a decision whether a feature is important or not, right? Then we understood different ways of calculating correlation, Spearman and Pearson. When the scales of the features are not same, then you should definitely go with Spearman correlation. Now let us try to understand correlation is not always causation. There is a lot of importance to business knowledge. So if you look at the below example, right, it actually represents that. Okay, sometimes we may look at some graph or chart or a statistical outcome and may get a misinterpretation of what's happening in the real business. So if you look at this, right, on y-axis we have taken number of casualties, and on x-axis we have taken firefighter count. This data is about wildfire. Okay, so on the x-axis, if the number of firefighters are increasing, right, 10, there is 1 casualty, 20 firefighters, 2 casualties, 30 firefighters, there are 3 casualties. But when number of firefighters are increasing, the casualties are increasing, right? It looks like, right, the casualties and number of firefighters are positively correlated. But that's not the truth, because when number of firefighters are increasing, the casualties should reduce in real time or business scenario. If you look at the other graph, right, the area square kilometers and the number of casualties. If you look at the area square kilometers, with the area square kilometers increasing, the number of casualties also increasing. Here the real reason is the area square kilometers, not the number of firefighters. The area square kilometers is more. That's when the more firefighters are being deployed. Even though more firefighters are deployed, because of square kilometer area is too big, the number of casualties are happening more. So this variable, the area square kilometers, is the root cause for the number of casualties. So the root cause parameter or the feature is called as confounding variable. When you have the business knowledge, you will understand that the area square kilometers is the root cause or the causing parameter, which is actually making the number of casualties. If you don't have business knowledge, only statistical knowledge, then you may infer that the number of firefighters is what is causing the number of casualties. So this is called as confounding variable. The area square kilometers is the confounding variable, and correlation is not always causation. You should have business knowledge, and with business knowledge you need to make the decision whether a feature is important in predicting the other feature or not. So I hope you understood, the correlation is not causation and confounding variable. But let us take another example. We are using the employee data set so far, so we have the similar kind of scenario there also. Let me show you that and explain. So if you look at these two graphs, right, on x-axis I have taken salary, and on y-axis I have taken the lines of code. Okay, so if you look at this graph, what is happening is, with the salary increasing, the lines of code is decreasing, right? If you look at 90,000 salary, the person, the lines of code is too low. If you look at 20,000 salary and the lines of code, it is too high, right? With salary increase, the lines of code is decreasing. That actually looks like the employees are reducing their coding effort when you increase salary. That's not the reality. If you know how the companies work, the software companies work, if you look at the second graph, right, you will understand. With the experience increasing, the salary is increasing. The root cause here is experience. With the experience increasing, the salary is increasing. It is not that when you increase the salary, the person is reducing the coding effort. With the experience increasing, the position increases, and more managerial and monetary roles will the person will get into, and the coding effort will reduce because of lack of time. So here the confounding variable is experience. So when you know the business, you will know which is the root cause and which is the more important feature in making prediction. When you know the important feature, you can actually eliminate unimportant features and keep important features and build a model and get more accuracy. Basically, machine learning algorithms needs a data scientist or artificial intelligence help in deciding the important features. So the statistical tools and business knowledge will give you that clarity and the decision making power. So let us look at coding of how exactly we have done this this visualization code, right, visualization thing. So here I have taken this data set of firefighters thing, right, the wildfire thing, the firefighters count and number of casualties and area square kilometers. I have taken 3 columns there and I created a data set there. And then right here I am doing a cat plot, the categorical plot, which actually takes 2 categorical variables and tries to do a bar chart. So the firefighters is a categorical variable. Casualties also, I have taken it as categorical variable because it's a discrete thing, countable, right? It's a small data set. And area SFT is also categorical. They are really speaking, they are real numbers. But in this particular data set, they are discrete. So I can take them as categorical. And then I am doing a cat plot. On x-axis, I have taken firefighter count. On y-axis, number of casualties. From which data frame it should take. The data frame is passed the kind of plot we want to do. In cat plot, you can do scatter chart and other plots also, the bubble chart and other charts also, right? And on the second graph, right, I am doing 2 plots. One between firefighters count and number of casualties, and the second plot on the area square kilometers and number of casualties. Okay, so if I execute this, right, I am getting the below 2 graphs. So we are actually learning visualization in parallel with statistics. We are going to apply or use these in building models. And for our data set, right, the employee data set, if you look at the data, I have done a scatter chart because both are numerical values, right? The salary is a numerical value, and then lines of code is also a numerical value. Then we have to do a scatter plot. So I have taken plt.scatter and passed the series object, x object and y object, and then specified color as red, and plt.x label and y label, which actually gives you labels here, salary and lines of code. And then for the second one, I have taken experience as x-axis and salary as y-axis, right? I have just plotted it. So this is just visualization, right? The confounding variable here is experience, and here area SFT is the confounding variable. I hope you understood the concepts in the correlation, covariance, and linear relationship representation using correlation and all those things. Let's meet in another session with new topic. Thank you.